So, okay class, for example number 3, the cantilever beam in figure A carries a triangular load, the intensity of which varies from 0 at the left end to 360 pound per feet at the right end. In addition, a 1,000 pound upward vertical load acts at the free end of the beam. Derive the shear force and bending moment equations and draw the shear force and bending moment diagrams, neglecting the weight of the beam. So we already have, so we have here the figure. Okay, ito yung sinasabi ko doon sa example number 1, wherein dito pa lang, dito magkakaroon ng vertical later on pagka plinat natin yung moment diagram niya. Okay, so first, we're going to solve for the reactions. We have the reactions RB and the moment at B. Wala ulit po siyang reaction along X kasi wala naman po tayong external load along X. Okay? So, we do summation forces Y for us to solve for RB. 1,000, positive 1,000, it's going up, plus your RB minus 1/2 of this uniformly distributed varying load. Okay, so we have, ang pagkuha natin ng resultant nito class, hindi ba yung kapag ganito is 1/2 base times height lang siya. So we have 1/2 multiplied by 12 multiplied your intensity, which is your 360 pound per feet. So that will give us the RB equal to 1,160. Next, we're going to do summation moment at B equal to 0. That will give us 1,000 multiplied by 12 minus your moment at B, negative kasi counterclockwise, minus your 1/2, 12 times 360 multiplied by 4. Paano nakuha itong 4 class? The resultant for this varying load is acting at the 1/3 of the figure from the highest. Okay? Mula dito, 1/3 po siya. Doon nag-act yung resultant. Kaya, if we divide it, this one, 12 divided by 4, divided by 3, that is equal to 4. Okay, so that will give us the value of MB, moment at B, that is equal to 3,360 pound-feet. So, ito na yung FBD natin class for the figure. Looking at it, since from A to B, uniformly varying load lang yung, distributed load lang yung meron siya. So, we only have one segment for this figure. Okay? So, meron lang tayong isang cutting plane. Ito lang yung cutting plane 1. Okay? So, if we're going to cut this one, ito na po yung magiging itsura niya. We just need to consider a part of this uniform load. Okay? And since sabi nga natin sa dalawang previous examples natin, since kinat natin, magkakaroon tayo ng shear and moment dito sa cutting plane dito. And the distance of that one will be x from the leftmost part of the figure. So sa part 1, so dun sa question, dun sa problem, we just need to know the expressions for the shear force and the bending moment. So if we do summation forces Y equals to 0, taking upward positive, considering this figure, we're going to have this equation. The 1,000, it's going up, minus your 15x squared. 15x squared po, 15 x 1/2 kasi 1/2 base times height, di ba? Ito yung pagkukuha natin. So 1/2 multiplied by x multiplied by 30x, that will give us 15x squared minus your shear, okay, kasi going down, and that will give us an equation for your shear force, and that is 1,000 minus 15x squared in pounds. Next, we have the moment at C. We're going to make a moment at C equals to 0, taking counterclockwise positive. So we will have this 1,000, negative siya kasi nag-clockwise yung direction niya, multiplied by x, that is the distance, plus your 15x squared multiplied by the distance nito. Okay, distance ng resultant ng 15x squared dito sa point na to. That is x over 3 plus your moment here at C. And that will be equal to 0. And that will give us an equation that is 1000x minus 5x cubed pound-feet. That will be the expressions derived for the shear force and bending moment for the segment of the beam. Next is the part 2. Sabi dun sa part 2, we have to draw the shear force and the bending moment. Okay? So ito na po yung shear force diagram and moment diagram natin. As you can see, dito pa lang nagkaroon na tayo ng first degree na slope. First degree na yung slope natin. Pagka gagawin natin yung shear, magiging second degree na class yung curve niya. Okay? And kapag nagpa-plus 1 lang siya, if this is first degree, this will be second degree, and your moment will be third degree. Okay? So, for the part 2, yan, ito na yung ating diagram. If we're going, we just consider this equation. If you're going to plot this one, we will have the values. Magiging ganito yung ating curve class. Ito siya. Okay? So, if we substitute 0 here, the value will be 1,000. Kaya 1,000 doon. Okay? If we go along this one, mapaplat natin ito. Palitan nyo lang tong value ng x para makuha natin tong curve na to. And then at this point, wherein your x is equal to 12 feet, palitan nyo to ng 12 feet. And you will arrive for negative 1,160. That is your shear force at this point. Okay, next, sa moment naman. If we do moment, if we substitute 0 here, you will have a 0 moment here. Okay? So, continuing from, ituloy-tuloy mo lang siya i-substitute, magkakaroon ka ng value. Ay, magiging ganito yung plot mo, hanggang sa 12 feet. Okay? So, kung iso-solve natin, kung gagawin mo tong part na to, wherein itong part na to itong x na to gagawin mong 12 feet, magkakaroon ka ng value na 3,360. Okay? And, tingnan mo, kung isipin mo, parang kung wala itong part na to, parang nakahang lang siya, class. Okay? Pero dahil nga may moment pa tayo doon, kaya siya bumaba ulit. Okay? So, this is the diagram for this figure. But how are we? So, ayan class, this part, since considering na wala pa tayong nasusolve dito, this part is where your shear is equal to 0. And we can actually solve for that. We can solve for the location using this equation. Since 0 yung shear dito, papalitan lang natin tong si V ng 0. 0 kasi siya dyan eh. So, we will be able to solve for x. Kaya ito na po siya. We have V, the shear force, equals to 1,000 minus 15x squared, and that is equal to 0. And we will be able to solve for x, that is equal to 8.165 feet. Okay? So, the maximum bending moment occurs at the slope equal to 0 at the maximum point dito. And that is actually where your shear is equal to 0 din siya. Okay? So, if we're going to differentiate this moment equation dito, we will have 1,000, dm is equal to 1,000 minus 15x squared dx, di ba? So, putting down your dx, magiging ganito yung itsura niya. So, dm over dx, that is equal to 1,000 minus 15x squared. And that is equal to 0. That is where the maximum moment is. Okay, so if we're using this equation, actually it is the same as this one. So we will be able to get for an x as well, that is equal to 8.165 feet. Yun magiging x niya. That is the location of your maximum moment. Okay, since alam na natin yung value ng x, we will then substitute that with this value para malaman natin kung ano yung maximum moment ng figure natin. So, substituting, so we have here 1,000 multiplied by your x, that is 8.165 minus 5 multiplied by 8.165 cube, and that will give us a moment of 5,443. That is your maximum moment.